Given question, find the resultant of force system acting on lamina of equilateral triangle.
We have to find out resultant of all these forces acting at different points of the triangle. If we observe these forces acting at different points, so we can say that these are non-concurrent forces. So we will first find out magnitude as well as direction of the resultant. So for that we have to resolve these inclined forces into two components, horizontal component as well as vertical component. So the angles are mentioned in the diagram. So for this 120 kilonewton I will draw here horizontal component and one vertical component. So how we can define this horizontal component? So it is nearby to angle 30 degree. So 120 cos of 30. And for this vertical component 120 sine of 30. In the same way we will resolve 100 kilonewton force into horizontal component and vertical component. So this horizontal component is nearby to angle 60. So 100 cos of 60 and here 100 sine of 60. Now how to find out the resultant? So we have to first find out the horizontal component of the resultant known as Rx and vertical component of the resultant known as Ry. So to find out Rx, we have to take the summation of all the horizontal forces acting on the system. That is Rx is equal to summation of Fx. That is the forces along the horizontal line. And to calculate Ry, we have to find out summation of all the forces along a vertical line. That is summation of Fy. So we will first find out summation of Fx and summation of Fy. So summation of Fx, that is nothing but Rx, is equal to. So first one is 60. So here is 60. So first one is 60. Now if we observe, we have to decide the sign. So towards the right hand side we will take positive sign and towards the left hand side we have to take opposite sign, that is negative sign. So we will take 60, then here is 100 towards the left hand side. So we will take minus cos of 60 and here is this force is also towards the left hand side. So minus 120 cos of 30. So when we solve this, then we will get minus 93.9 Newton. Now for negative sign we have to use the direction towards left hand side. So we can take here which is equal to 93.9 Newton and direction is here. Now we will find out Ry, that is summation of Fy. So we have to take all these vertical forces. So for the downward direction we have to take negative sign. And then for upward direction we have to take positive sign. So again we will solve this. So minus 80, then plus 100 sin 60, minus 120 sin 30. Then we will solve this. So it is minus 53.40. So it is minus sign. So here is negative sign for downward direction. So we can write 53.40 Newton and direction is downward. So how we can find out the resultant R? So R is equal to under root of Rx square plus Ry square. So Rx is 93.9 square plus Ry 53.4 square, which is equal to 108 Newton. So this is the magnitude. Now we will show here the direction of this resultant. So we have to draw this horizontal component and vertical component. But when we draw this, we have to remember at the end point of one force, we have to start the another force. So if I take first this vertical force with magnitude 53.40. So I will draw here, the direction is downward direction. It is Ry and magnitude is 53.4. Now here horizontal component is 93.9. Now it is greater than 53. So we have to draw here slightly greater line. And this is Rx. So at the end point of one force we have to show the start point of other. Direction is towards left hand side. This is known as Rx. Now to show R, we have to connect start point of one force and the end point of the other force. So we will show here R. So this is the direction of R. Now how to find out angle of inclination of this R? So suppose if I show here alpha, then from this diagram tan of alpha is equal to Ry by Rx. So value of Ry we have to put 53.4 divided by 93.9. So alpha is equal to tan inverse of Ry by Rx, which is equal to 29.6 degree. So we can say that it is this angle 29.6 degree. Now we will consider any particular distance x, that is approximate distance x, and at a distance x this resultant R is there. So I will show here. So we will take here one point as a point A, and from this point A I will show any distance x. So this is the approximate distance x, and at this distance x we have to show this resultant R. So if I show the angle of inclination is 29 degree, so here is this angle R. Now at this R we have to resolve this R into two components. First is Ry, that is vertical component is known as Ry. So this is the Ry. So we have to show this. And then second component is Rx. So we will show. This is the Rx. Now to find out this unknown distance x, we have to apply the principle of moments or Varignon's theorem. Now according to this Varignon's theorem, moment of all these forces about any point or about moment center is equal to moment of resultant about the same moment center. Now we will take moment of all these forces about point A. We will apply Varignon's theorem. So we will first take the moment of these two forces. If we observe, we have to take this 80 kilonewton force multiplied by the perpendicular distance. If I draw one line of action of force passing through this vertical force, then here is the point of intersection with this horizontal line of triangle, and this is equal to P. So perpendicular distance is nothing but distance AP. So we have to observe the triangle ABP. So how to find out distance AP? So this is the perpendicular distance. So if we observe, then this cos of 60 we can write here as a nearby side, that is AP divided by AB. So I will write here cos of 60 is equal to AP divided by AB. Now in question it is given that each side, because this is the equilateral triangle, so each side of this triangle is equal to 100 millimeter. So AP is equal to 100 cos of 60. So we have to take 80 multiplied by 100 cos of 60. Now if I move the compass about point O in the direction of 80 kilonewton, so here is this clockwise direction, and for this direction we will use positive sign. So 80 multiplied by 100 cos 60. Now we will move here the 60 kilonewton. Now here is the line of action of force. Then we have to show perpendicular distance from point A. So this vertical line is the perpendicular distance. So this distance is equal to the distance B to P. So we have to find out distance B to P. Again from this triangle ABP, we can say that this B to P distance is equal to this 100 sine of 60. So we will write 100 sine of 60 multiplied by this 60. Now if I move the compass about point A in the direction of 60 kilonewton, that is in this direction, then here is also clockwise direction, and we have to use positive sign. Now we will move to the next, that is 120 kilonewton force. This horizontal component is passing through the point A. So perpendicular distance is 0. Now this vertical component, this is the line of action of force, and this is the perpendicular distance, that is distance A to C, and that is equal to 100 millimeter. So we can write here 120 sine 60 multiplied by 100. Now if I move the compass about point A in the direction of 120 sin 30, then it is clockwise direction. So plus 120 sin 30 multiplied by 100, which is equal to, now we have to take moment of this resultant R. So for this horizontal component, Rx is passing through A, so it is 0. Now this Ry, so if we observe, we have to take perpendicular distance from A, so it is distance x, so Ry multiplied by x. So Ry is known, we have calculated, and x is equal to 284 millimeter. So why here unit is millimeter? Because if we observe, unit given is in terms of millimeter in the question, so we have to repeat here same unit.